All right, Sandor, we're live.
All right. Thank you. It's a pleasure to be part of this Fermentology series. I'm here in my kitchen in Tennessee, and I have all kinds of show and tell items. And our theme today is vegetable fermentation. And, unlike a sourdough or really any fermentation of grains or of beans, which have nothing to do with preservation. They have to do with digestibility. They have to do with sort of lightness of the bread. They have to do with nutrient bioavailability. But nobody ever ferments grains in order to preserve them because they're so stable in their mature form. When they dry on the plant, and then you can just keep them, in a jar or a bag until you're ready to use them. And then the first step of the fermentation is always introducing water, which awakens the dormant organisms that are on them. Vegetables, it's a very different story because vegetables, to varying degrees, are perishable. And generally, the primary motivation for fermenting them is preserving them. And so, in general, you see, more traditions of fermenting vegetables in colder places with short growing seasons and long winters without fresh vegetables, than in tropical places where vegetables are available all year around. But that doesn't completely hold true. In terms of the fermentation of vegetables is driven by lactic acid bacteria. And, one of the things that microbiologists and botanists have learned is that all plants have lactic acid bacteria. All plants growing out of soil on planet Earth have lactic acid bacteria. It doesn't necessarily hold true for, let's say, hydroponic vegetables, but anything growing out of soil has lactic acid bacteria. So the bacteria that we need to ferment vegetables is always on the vegetables, but it's not the only organism on the vegetable. And so, the big question with fermenting vegetables, as with fermenting most things, is, which of the multitude of organisms that are present on the food that we are fermenting, the substrate for the fermentation, which of those organisms are going to grow? And so, really the practice of fermentation has a lot to do with manipulating environmental conditions to encourage the growth of certain organisms while simultaneously discouraging the growth of other organisms. So for instance, if we shred cabbage, which is the first step of making sauerkraut, and put some salt on it, and then we leave that cabbage loosely shredded in the bowl, it's never going to turn itself into sauerkraut, and it's very predictable what will happen, which is that molds will develop on the surfaces. And I just so happen to have a piece of cabbage that has been sitting in the drawer in my refrigerator for like 3 weeks or something. And do you see this darkening of the surfaces? This is mold. And if you had a whole bowl of loosely shredded vegetables where all the surfaces had good air circulation and therefore access to oxygen, you would see these kinds of, dark, fuzzy molds developing on all of the cabbage. And so, the environmental manipulation for fermenting vegetables in general is to get the vegetables submerged. And what this does is it protects them from the flow of oxygen and makes it impossible for molds to grow, except on the surface, which is the most vulnerable place. But within the volume of it, molds can't grow. And what will dominate instead every single time are lactic acid bacteria. Now, to say that vegetables are fermented by lactic acid bacteria is a little bit of an oversimplification, because what's really happening is that there is a succession of different strains of lactic bacteria coming into dominance in that environment as the fermentation proceeds. So the community of organisms, on the vegetables, the composition of that community is evolving over the course of the fermentation, and it's being very much influenced by the changing environmental conditions, specifically the pH. So as the environment becomes more acidic, due to the early stage lactic acid bacteria producing lactic acid, it gives rise to other strains coming into dominance. And so, generally the organism that initiates it, which is a lactic acid bacteria that is believed to be universally present on plants growing out of soil on planet Earth. And for microbiologists out there, I might be butchering the pronunciation of the name, but Leuconostoc meserontoides is typically what initiates the fermentation and begins to generate some lactic acid. But as the environment becomes more acidic, it gives rise to more specialized populations. And in a fully acidic fermented vegetables that have had several weeks of fermentation and reaching a pH of below 4.6, typically what's dominating is Lactobacillus plantarum. So you have a succession of different organisms developing as the ferment matures. This acid is what makes this so safe. I mean, fermented vegetables, statistically speaking, are much safer than raw vegetables. We hear every year of, outbreaks of food poisoning related to raw vegetables. Usually the story is, manure from a factory farm uphill washed over some vegetables and ended up making some people sick. But even if you took vegetables like that and fermented them, as the lactic acid bacteria generate lactic acid, they would destroy the potentially pathogenic bacteria. So, like any kind of acidified foods, the fermentation of vegetables is a strategy for safety, which enhances the safety of these foods. And in fact, fermented vegetables Fermented vegetables are, I'm sorry, that was a phone call coming in through my computer. Fermented vegetables are among the, most, the safest foods that are known. Let me talk a little bit about preservation, because in our time, I mean, a lot of people can their sauerkraut. They use heat processing to make their sauerkraut even more stable, so that they can eat it for years. Canning is a relatively new process. Canning was invented a little bit more than 200 years ago in France. They call it appertisation because they remember the name of Nicolas Appert, the Frenchman who invented the of stabilizing food using heat. But the fermentation of vegetables for some period of time. So one of the show and tell items that I have today are I call it radish kraut. It's daikon radishes and some cabbages that I made in November. And it was really sitting in a vessel in my cellar, my unheated cellar that more or less stays the earth temperature in the winter time. And it was there, it was there, let's say from November until the end of May. And then it's been in my refrigerator since then. I'm sorry, that phone call confused me a little bit. But the reason why it's been in the refrigerator since then is that once we get to summer temperatures and temperatures in the 90s during the day, my root cellar warms up. And it's not that this would become dangerous or toxic, it's that the texture would change, and it would go from being something crispy, which it is now, to something soft and mushy like baby food. And basically what that is enzymes. What makes the vegetables crispy are pectins, and there are enzymes, pectinase enzymes, that digest the pectin. And once it gets warm, or if you don't use adequate salt, then those enzymes will end up making it soft and mushy. So by the time temperatures are really warming up, I like to move this into the refrigerator for longer preservation. But it's really only through that cool part of the year that there are no fresh vegetables. Like, that's what the practical survival aspect of this preservation always has been, to get people through the cool temperatures. And I ferment all year round. I mean, I have examples here. You know, this I just made the other day. This is like little sour Mexican gherkins that are fermenting. But I'll just ferment these for like a week, and then I'll eat them or put them in the refrigerator. You know, this is in the summertime. This is a technique to flavor things and extend their life for a little while. But you really need cooler temperatures to do long-term preservation. And, you know, the things that I'll ferment for long-term preservation, I'll be making them in October and November. You know, whereas the things that I'm making now in the summertime are a shorter term endeavor, just because I live in a place where it's very hot. Okay, let's get into some history of this. I mean, this is an ancient practice. No one can say exactly how ancient. All of the historical literature suggests that the idea comes from China, and that nomadic people of Central Asia encountered the idea of preserving vegetables through fermentation and spread the idea westward. You know, this story is repeated throughout the literature. You know, I can't really, you know, speak to, you know, what the origin of this story is. There's a lot of different techniques. The easiest technique is the dry salting technique. All you do is you shred your vegetables to create surface area, and then salt them. And the salt starts to pull juice out of the vegetables. And the objective is to get the vegetables submerged under the juice to protect them from the flow of air and oxygen and molds growing. So you shred vegetables, salt them. You can salt them very lightly. There's no minimum amount of salt that you need. I mean, it's possible to do it with no salt. It doesn't taste very good. It won't maintain a very good texture. So salt it. You know, the USDA number is 2.25% salt. I mean, that's really, for me, that's too salty. For most of the small scale commercial producers that I meet, that's too salty. Most of the small scale commercial businesses that I'm meeting are using somewhere around 1.5% salt. But honestly, I typically don't measure the salt when I'm dry salting. I lightly salt as I'm shredding the vegetables. I mix it all together. I get in there with my hands and squeeze for a few minutes until everything's nice and juicy. The squeezing breaks down cell walls and helps release juices. And then once everything's juicy and mixed up, I'll taste a little piece and I'll just evaluate the saltiness of it myself. So here, this is for a demo a few weeks ago. I made this. This is just sauerkraut with cabbage and a little bit of carrot and some caraway seeds. And I have a little, you know, I'm just doing it in a quart-sized mason jar. Wide mouth is always easier. And then I have this little glass disc, which is functioning as a weight. Keeping the vegetables down, forcing liquid up so that the vegetables remain fully submerged. So this is a newer one, a shorter term project. I already showed you this one, which is the radish kraut. Now, because this one fermented for so many months, this has a really, really intensely sour flavor. Like, I love it. Some of you would love it, but you know, probably some people you know would taste this and just, you know, just wince at it and just feel like that was too sharp of a flavor to be able to enjoy. Another variant of the dry salting is you can make things like relishes and sauces. So, you know, for instance, this is a hot sauce. So this is like habaneros, which I put in the food processor with garlic And then meanwhile, I cooked some sweet potatoes, cooled them down, and then I put the cooked soft flesh of the sweet potatoes mixed with the habaneros and the garlic and some salt. I mean, this I made last year, and I've been using this as a hot sauce condiment. So dry salting, that's when you're not adding any liquid and you get the most intense flavor of the vegetables that way. But the limitation of dry salting is generally you can't do a whole vegetable through dry salting. So, you know, the whole vegetable that got me, you know, as a kid excited about pickles is like this. So this is, you know, this is a cucumber pickle, no vinegar. It's in a brine. In my upbringing in New York, we called this sour pickles. And there's garlic in there and dill and also grape leaves. Like one of the challenges of fermenting cucumbers is that, well, they're ripe in the hot weather, and they have a higher concentration of these pectinase enzymes, and so it's easy for them to become soft and mushy. But of course, that's when they're ripe, is in the hot weather. So I always make sour pickles. I love them, but I just ferment them for less than a week at ambient temperatures on the counter, and then I move them to the refrigerator. And I'm going to just have a bite of this because I can't bear not to, because I can smell it. Okay, that's maintaining its crunchiness really nicely. I'm very pleased with that. Here's another batch that I made that's newer. These are with the Mexican Spanish gherkins. So these are in a brine, in a saltwater solution. Usually I mix the saltwater solution at around 5% salt. That's saltier than I want my pickles to be, but you know, an important concept is as little brine as possible to cover the vegetables. The more water you add, the more you're diluting the flavor of the vegetables. So you want to use, you know, less than half of your volume as brine. So what that means is if you use a 5% brine, you're ending up somewhere around 2% in your salinity. It's harder to just do it by taste because it takes time for the salt to absorb into the big vegetables, but you can always adjust it. If it, you know, if after a couple days it tastes too salty, you can add a little bit of water. If it tastes not salty enough, you can add a little bit of salt, so you can still adjust it. Then there are hybrid methods. So kimchi, typically for kimchi, what you do is you brine the vegetables for some hours or in some cases some days, and then you drain off that brine, and then you make a spice mixture, which sometimes involves some rice. Sometimes it could involve fish sauce. I mean, there's a lot of variation in what it could involve. This is a cucumber kimchi. It's called a stuffed cucumber kimchi because I've made these little slits in the lengthwise in the cucumber, and then when I was making it, I rubbed the spice mix into those. There's lots of variations of kimchi. They don't all have chili pepper. Here's another kimchi that's all green. It's greens, like mustard greens and bok choy. You know, and then there's other methods, like a lot of the Indian pickles call for the use of oils and sun. So this is like a lime pickle, a spicy lime pickle. And I sort of quartered each of the limes, but left them connected at the end, and then put salt and spices into them, stuffed them in the jar. And then for a couple of weeks, I put them outside in the sun on sunny days. And that helps to, you know, pull juice out of the vegetables. And then also I put a little bit of mustard oil into the mix. Japanese cuisine in particular, they have a lot of, like, you know, really interesting alternative pickling mediums. So an example that I have here, these are kasuzuke. So the pickling medium is kasu, which is the the residue of sake making, mixed with some sugar and salt. And then the vegetables are packed in there and fermented for a few months. Japanese cuisine also has nuka pickles made from rice bran, koji pickles, where koji is the medium, miso pickles, soy sauce pickles, of course, vinegar pickles, lots of different kinds. Let me just clarify the word pickle, because it confuses people sometimes, because most of what we see on supermarket shelves are vinegar pickles, and that is a pickle. A pickle is anything preserved in an acidic medium, and one way to achieve that is to pour a hot vinegar mix over some vegetables. Another way is to allow the acidity to come from the fermentation by lactic acid bacteria, and it's just a completely different flavor. Lactic acid versus acetic acid. They're both pickles. Acetic acid vinegar is made from alcohol, which is made from sugar. So, historically, vinegar has been kind of precious. It's really only mid-20th century when the process was developed for the vinegar that's cheaper than water at the supermarket, distilled white vinegar, that vinegar pickling became really, really widespread. But it has the advantage of making something that is more shelf stable, that can sit potentially for years. Fermented pickles are much more dynamic, but also they have what I would consider to be a much more interesting flavor, as well as the benefit of probiotics. I want to talk a little bit about brine, because after you ferment, you can end up with lots of extra brine. First of all, it's delicious. Like, drink it, use it. Don't pour it down the drain. It's full of flavor. It's also teeming with lactic bacteria. In some parts of the world, people use it medicinally. In Eastern Europe, this, pickle brine and sauerkraut juice are renowned as, hangover cures, but they're delicious. I mean, I use them in salad dressings. I use them as braising liquids. Sometimes I end up with so much of it that I'll cook it down. So this is a seasoning in my kitchen that I call eau de kraut. And this is basically like a kraut juice cooked down about 10 times. So, I started with let's say 10 gallons of brine and cooked it down to less than a gallon of brine. And so all that flavor is concentrated. So this is very salty and very acidic, but it's lovely as a seasoning for food. Sometimes I will reduce it even further in a dehydrator, and these are little crystals. This is crystallized. This is kraut brine crystallized into salts. Oh, with a very it's salty, but it also has all those other byproducts, and so it's very acidic, and it just has a lot going on. It's a really interesting seasoning. One other use for extra brine is I've been making mustard, and I've had some amazing mustards that people make. And rather than vinegar, or sometimes in addition to vinegar, but you soak your mustard seeds in kraut juice and then blend it down. And if you want to make it a little bit more acidic for longer keeping, then you can add a little bit of vinegar to that. So anyway, that's a little rundown on vegetable fermentation. Sometimes people get a little funky growth on the surface. And because we've all been raised to be so fearful of microorganisms and associate food poisoning with that, a lot of people have thrown away their kraut or kimchi or other vegetable fermentation experiments because it grew a little funky surface growth. Don't throw it away. Remove that surface growth as best you can, throw it in the compost, and what's underneath it is fine. This is typical, to be expected. Anybody who experiments in this realm is going to deal with surface growth. Sometimes it's a yeast called a comm yeast. Sometimes it's a hairy white mold. Remove it as best you can, discard it, and don't worry about it. In my travels in parts of the world where this has just been an important ongoing tradition that people are familiar with, they are so casual about that. Like, I was in China filming a video, and this chef of a giant restaurant just mixed the surface growth right into his pickles without a thought, without any self-consciousness that we were videotaping him. It didn't even occur to him that it would be an issue for anyone. This is a really normal part of the process. If it really disturbs you too much, there are specialized vessels that you can get that are designed to exclude air with oxygen, but give some kind of venting for the carbon dioxide that's produced by the process inevitably. That's the biggest and most common problem that people have. So now maybe there's some questions that Michelle is going to convey to me.
Loads. Where to begin?
Shocking.
You did tackle one that I had quite a few times from different people who were asking about mold growth. How do you avoid it? But I guess the answer is you don't need to. It's just part of what happens.
Well, no, I mean, okay, so ways to avoid it. More salt and or spices will, marginally inhibit it. A cooler space is the best way to inhibit it. But really, the best thing is to protect it from the free flow of air. So there's all kinds of specialized airlocked vessels. What they all have in common is that the carbon dioxide can get out. Like, you can't totally seal it. Otherwise, you'll create something that becomes more and more pressurized. So you need like a one-way valve, and that can be as simple as like a plastic bag filled with water or brine, weighting it down and covering the entire surface. Or it can be a jar that has a lid that has a little hole and a gasket and one of those little airlocks that people use for alcohol fermentation. There's specialized Chinese style of crock that has like a moat around it that you fill with water, and then a lid that fits inside that moat. So there's different concepts. I don't use any of them because I am compulsively interested in seeing, smelling, and tasting my ferments as they develop. And if you seal it off like that, you just have to pick an arbitrary date in the future to open it. And if you keep opening it to smell it and taste it, you're defeating the purpose of your elegantly designed technology. So I don't use any of it. I just skim the mold off if it happens, and try not to worry about it.
Okay. Do you have any advice for people working in hotter temperatures, places in the world like that?
Shorter fermentations. You just have to, this is great for, if you live in the north of Russia somewhere, this could be a 6 to 8 month process, and, no problem, as long as you have it in an unheated space. If you're, somewhere, in the equatorial regions where it just stays warm all the time, you can do this. Like, I've done this lots of times in tropical places, but you just have to reconceptualize it as a shorter term thing for flavor, for probiotics, and not for long-term preservation of vegetables. That's only possible with lower temperatures.
Thank you. We got a question from Peter Reinhardt, who's one of our speakers beforehand as well. He's asking, when you say 2.5% salt, is that the percentage of the weight of the vegetables or the water?
Well, okay. I guess I mentioned that the USDA recommendation would be 2.25% salt, and that's for dry salting. So you're not adding any water. So you're just weighing your vegetables, and that's as a basis of that's 2.25% as a basis of that. But I also said I think that that's too salty for me. There's no specific like safety threshold, because there's really no case history of illness or food poisoning from fermented vegetables. So it's more aesthetics. The vegetables will stay crunchy longer the more salt you use. So when I do this in the summertime, I always use more salt than I do in the wintertime, because the metabolism of all these organisms is so much faster in hot summer temperatures than they are in cooler weather. And then the salt slows things down a little bit, so you buy a little bit more time by adding more salt. When I'm talking about the pickles, where I mix a 5% brine, I ignore the weight of the vegetables. I'm just basing it on the water. So a liter of water weighs a kilogram. So 50 grams of salt for a liter of water is a 5% brine. Usually I do it by weight. In art of fermentation, I give some approximations about, how many tablespoons that is.
Nice, thank you. Another question about hydroponic vegetables. Is there any difference with them when it comes to the fermentation process?
Well, as I said, there's this general notion that, all vegetables have lactic acid bacteria because it's in the soil everywhere. But, I guess it's more of a question for me. Like, so, I mean, I would not assume that hydroponic vegetables have lactic acid bacteria. And that doesn't mean that you couldn't ferment hydroponic vegetables. It just means that you would want to make sure that you had some element in it that came out of soil. So, let's say you had cucumbers that were grown hydroponically. Use some garlic that grew in the soil as the source of the bacteria. Yeah, I mean, I just couldn't say, I haven't seen any analysis of hydroponic vegetables to know whether they have lactic acid bacteria.
Awesome. And Brittany was curious, how long can you eat, once you open your container, how long can you keep a fermented vegetable in the refrigerator? How quickly should you finish it by?
I mean, few years. I mean, what I would say is it depends a lot on how full the jar is. I mean, this is like oxidation. It drives like most food spoilage. So if you have a full jar of something salty and acidic that's at refrigerator temperatures, I mean, it's going to be fine in 5 years, 10 years. It should be. I mean, there's no reason to wait that long, but like, there's also no reason to worry about it if you find something that's been hidden in the refrigerator for a long time in a full jar. On the other hand, if you take a jar that is half empty and leave it in the fridge, that airspace has enough oxygen for molds to form over time. And just like in jelly or certain dairy products, you could find, a mold even in the refrigerator. That could happen with fermented vegetables too. And, if it sits there with the mold growing for months, I mean, not that the mold is going to necessarily hurt you, but it'll degrade the vegetables. It'll break down the texture of the vegetables. It'll change the flavor of the vegetables. So, anything you want to keep for a long time, keep it in the fridge in a full jar with less airspace.
Nice. Yeah, I suppose that fermented vegetables have been around longer than calendars have, right? So they don't care about shelf life so much. I could ask you 1,000 more questions, but I'm gonna stop on. I'm gonna ask you 2 more if you have time for it, Sandor.
Okay, great.
Skip's curious. He's a home brewer, and he wanted you to speak towards sanitizing, sterilizing containers, things like that.
Great. I mean, cleanliness and hygiene are always important in the kitchen. You always want to work with clean jars, clean tools, clean hands. Sterilization is really a fantasy. And I know that, home brewers rely upon this fantasy, but really you have to understand what's different about home brewing is you're taking a cooked substrate and you're trying to get a single organism to grow in it. So it's basically monoculture, and a lot of things can, potentially foil monoculture. And so, the reason why homebrewers tend to be so committed to, using chemicals to sanitize everything is that they're trying to get this singular organism, which really is a departure from the history of fermentation, to grow. With vegetables, the organisms that you want they're part of all of the vegetables that you're trying to ferment. And so, as long as your jar is clean and, and well rinsed so that all the detergent is off of it, and as long as your hands are clean, you don't have to worry about the random bacteria on your hands, or that were in the air in your kitchen and ended up on your cleaned jar. There's a critical mass of the organisms that we want that will be able to dominate in that environment, even if there's, some random, cells that end up on the jar. So you don't have to worry about, sterilizing everything, using any particular sanitizing chemicals. Soap, water, enough water to get all the soap off is totally adequate.
Excellent. That's good to know for all of us. Makes me a lot more confident in the process. And then last question, it's a few people have asked this one. What's your favorite recipe? What's your favorite vegetable to do?
Well, honestly, my favorite vegetable to do is whatever I have a lot of. The way I end up doing, so I have a 200-liter vessel. So that's, about 50 some gallons in my cellar. And every year I go to my friend's biodynamic farm an hour and a half north of here, and he plants daikon radishes as a cover crop. So I can harvest 500 pounds of daikon radishes, and he barely even notices. And so that's why I make a big batch of radish kraut every year, because that's what I have access to a lot of. I will say a few years ago, a friend of mine showed up with buckets of ramps, and I had like maybe 10 pounds of ramps. Ramps are these wild alliums, something between like onion and garlic and leek, but that grows in the forest. And I know I have a place where I always harvest a little handful every year and make an omelet, but my friend showed up with like buckets of them, and it was like 10 pounds of them. And I made ramps kraut out of just ramps and salt, and that was incredibly wonderful. It just had such a sort of sublime and wonderful flavor. So but I love to ferment okra. Cucumbers are my historical favorite. I never get tired of eating a cucumber pickle. Green tomato pickles I love. Green beans I love to ferment. There's I like a lot of different things. I've had wonderful fermented butternut squash as a puree. But really, rather than a particular recipe, I love fermented vegetables. I've hardly ever tasted fermented vegetables that I didn't think were really delicious. Maybe something that I thought was too salty or too spicy or something like that. But don't be afraid to experiment. Like there's any vegetable you could buy in the supermarket, any vegetable you could find in your garden or at a farmer's market, you can ferment. Now that's not to say that you're with every vegetable. It's just that you could potentially experiment in small batches so you can see what you like and what you don't like. You can ferment kale exactly the way you ferment cabbage, but as much stronger flavor. And you love that, I can't tell you.
Awesome. Thank you so much, Sandor. We're breaking up a little bit towards the end. I wonder if it's raining over by you again. But thank you so much. On behalf of the almost 200 people that are watching right now, I also just want to quickly plug our next talk is actually going to be August 27th. Yes, we are coming into August now. Can you believe it? That's going to be with Josie Baker, and be talking about bread baking as an opportunity and also how it's involved with community upliftment. So that should be a really exciting talk. If you haven't already RSVP'd for it, please do. Otherwise, you're just gonna hear me clapping, but thank you so much, Sandor, for your time and your expertise.
Sweet.
We really
appreciate it. Here, let me just, I forgot to plug my books.
Oh, please.
Wild Fermentation and The Art of Fermentation.
Head to your local bookstore and pick them up. Thank you so much, Sandor.
Thank you so much.
Bye.